Hello, and welcome back to another episode of AI Frontiers, where we bring you conversations with the people currently working at the far edges of artificial intelligence. Before we get started, I want to tell you a little bit about Valory. Valory is the premier creator of open source frameworks for co-owned AI, and it's our mission to empower communities, organizations, and even countries to co-own the AI systems of the future. It's our belief that artificial general intelligence will likely be agentic, and that's why we found it important to take this moment to bring you a broad range of perspectives from people currently working in the space. One of those people is today's guest, Chi Wang. He's a principal researcher for Microsoft Research, and he's also the creator of AutoGen. I found this conversation particularly engaging, and I think you will too. So here's my conversation with Chi Wang. Yeah, it's great to have you here. Thank you for making the time, and great place to start would be you could tell me your name and what you're currently working on.
Yeah. Hi, Thomas. My name is Chi Wang. I'm from Microsoft Research. I'm working on the AutoGen project. I created it last year, and now I'm leading the research and development of this project.
Awesome. Well, I look forward to hearing a little bit about that and diving into your experience with AI and AI agents in particular. On that note, a perfect place to start is if we define our terms. And I'd like to know, how do you currently define an AI agent?
Yeah, that's a very interesting question. I do have a very long answer to that. The reason is, there are so many different definitions of AI agents. It's used in many different occasions. So I want to give you a more comprehensive view from my perspective. When I design AutoGen, I really think about what is the most comprehensive definition of agent so that we can incorporate all these different kind of notions. So I'm trying to find the minimal set of concepts necessary for AI agents and try to remove all the secondary considerations and make them compatible with the definition. Right now, my agent definition is they are the entities who can act on behalf of the human intent. They can send messages, receive messages, perform actions, and generate reply, and interact with other agents. So that's still a little bit abstract. So if I want to make it more concrete, I would say by definition of AI agents, cover a spectrum of different complexities of these kind of agents. For example, you can compose complex agents using simpler agents. You can have nested chat inside the complex agent to recursively build up more and more complex agents. Or you can have very simple agents that perform relatively simple functions. In AutoGen, every agent the simple agents can use different types of backends to support that behavior. They can use large language models, or in general, any AI models, or they can use tools that are not models, but also are useful to generate certain kind of responses. And third, they can use human input as the source of the response. But all the agents in AutoGen are convertible and customizable. So that's the commonality. And they all share the same unified interface. And on the underneath, they can have, like I mentioned, either simple responses using a single source of backend, or they can contain arbitrarily complex inner conversations like nested chat between other agents. So in this way, we can define both very powerful agents that are composed of like many different agents inside it, or we can define relatively simple agents and use them as a basic units to build more complex systems. So this is my definition. I also want to talk about in a different dimension about when people think about agents, they sometimes think about them in different contexts. So I want to make some clarification about that. For example, sometimes people talk about them as an interface. So that means users have the experience to talk to some agent, for example. In those cases, they can think about this interface, and they can say when users talking about this interface, they have the perception that they are talking with a single agent. So that's an interface point of view. But there's another point of view about the software components, right? You can think about agents as some basic units to compose a big AI system. So they perform many actions that are not necessarily all observable by the user. When user talks to, for example, a assistant agent, underneath that assistant agent may talk to a few other agents performing different jobs, but the user doesn't necessarily need to know that. So in that case, those other agents, we consider them as software components. So this is like the architecture view about agents. So I think both are important. The interface view mainly emphasizes that the experience from some end user point of view, they have the experience of working with a very strong agent that can do many different tasks. But the software view provides us a path to build such experience. So even if you want eventually build a single agent experience, you could still use multi-agent as architecture to build a system. So yeah, so I hope that provides some clarification about what I'm thinking about the agents.
Yeah, that's great. And I'm glad that you touched on that agentic action is a way of acting in the world. It's not quite as narrow as just the assistant model where you send an instruction. But yeah, as you said, below the surface, there can be things that are not necessarily observable. And I think that's really interesting and will be quite relevant for a lot of my audience who arrived through multi-agent system approach. And so I'm really glad you touched on that. It would be cool to hear you maybe provide an example of something that you do consider an AI agent and then contrast it with something that you don't consider an AI agent. I think maybe we can see something interesting there.
Yeah, that's interesting question. So I think from interface, we can continue using our terminology before. If you think about the interface, then what is considered as a agentic interface and what is considered as not agentic interface? I think that's an interesting question. So I think for many users, they would think about agentic interface as some interface which they perceive as contains certain level of intelligence and degree of autonomy, right? A chatbot is a very typical kind of interface, and assistant, like personal assistant from mobile or from web, can be considered as agentic interface. And what is not agentic interface? I think when people use a traditional software with GUIs, where people need to click buttons and explicitly ask for a relatively straightforward action to perform and get the expected behavior, many traditional software like or service have that interface. It's basically a function call, and you ask it to perform a certain functionality with certain parameters bindings, and you can basically get back the simple result. But this, I think what I said is I'm not happy with my answer because it's a bit fuzzy, because it's kind of it's quite subjective. I feel like in the scenario described, it sounds like if the user has very straightforward expectation of the result, then it sounds like that's agentic. If the user doesn't expect the software to, or user didn't expect the solution will be used by the software, but the software can sometimes come up with the concrete solution without the every detailed instruction provided by the user. It's considered more agentic. But when you use definition, we notice that this is related to the user expectation, right? In future, if even for complex tasks, all the users expect the system to come up with a straightforward answer without any different alternative paths, then even that complex task can be considered as non-agentic. So here, I think the dimensions we want to consider is both complexity and autonomy, and whether there are multiple alternative solutions to the problem, and the system is able to figure it out on its own. And also, maybe another dimension is whether there's this conversational interface that the user can iterate back and forth. If something doesn't work, the user is able to provide further clarification and get better response. Maybe that's also an element that's considered as important as agentic versus not. Yeah, I'm sorry, I don't have an answer. I like myself. None of them is scientific. None of this is very rigorous. But I want to come back to my earlier statement about the AutoGen's agent. AutoGen agent doesn't try too hard to draw a boundary between agent and non-agents. It tries to incorporate the broadest sense of agents. For example, even tool-based agent that only performs certain determinist behavior, like executing a function or executing some code suggested by another agent and send a response back. That is valid agent concept in AutoGen. The reason is AutoGen wants to offer these agents not only as interface to the end user, but also as a software component, so that developers can build complex AI-based applications using them. So we want to keep the relatively simple agent which performs even a certain tool-based action. We want to incorporate that as a one type of agent so that developers have all the necessary type of agents they need, even though they are not typically regarded as agent in terms of the interface that the human deals with, right? So yeah, I guess a general conclusion I had is when we think about the software components, we want to be broader and incorporate some relatively simple agents as valid agent concept for convenience, to have a unified way to build arbitrary complex applications. But when we come to the interface, then I guess there's higher requirement to the intelligence and conversability, ability to handle complex tasks when for people to qualify them as agents. That's probably my take.
Yeah, for sure. And I completely understand it's a very fuzzy and difficult to define. I'm glad that again you're mentioning that tool-based agents can be composable into larger systems. And this brings us back more to the way the term agent was used maybe 4 or 5 years ago. We're talking about multi-agent systems or agentic behavior, swarming, these kinds of things. What we can add in with LLMs is another kind of agentic behavior, but it's what's most interesting to me is that you can stack these things together in a way that allows you to, when you hit a unexpected complexity, what happens after that, often where I see what I consider quite agentic behavior. So I'm glad you're mentioning all of these, even though the space is quite fuzzy. I'd like to hear about your background. So maybe you could tell me how you got into the field or how you started working with AI.
Yeah, thanks. Let's see, where should we start? So okay, let's go backwards. Right now, I'm a principal researcher at Microsoft Research AI Frontiers. I've worked on large language model and AI frameworks, automated machine learning and hyperparameter tuning, model selection, machine learning for systems, scalable solutions for data science, data analytics. I'm the creator of AutoGen, and I also the creator of Flamo, another open source library for fast AutoML and tuning. It's also a widely used project in both inside and outside Microsoft. So yeah, so you can see that I worked on a variety of different projects in AI, machine learning, systems, data science. My PhD is in data mining, but I did text mining, graphic mining. At that time, by the way, I want to mention an interesting thing. At that my PhD time, I was also working on generative models for text, for natural language, but it's very different from today's generative AI techniques, the large language models. Back then, it was very small models with high interpretability. There are the probabilistics models, something called Bayesian networks. So probably to the younger generation today is not familiar with that, but they are indeed generative models, and also language models that can be used to model text data. But it's amazing to see how fast the technology evolves. So now today, a lot of the dreams earlier become true, right? We can now make very powerful AI agents based on these strong models. So that's kind of short, maybe background myself. Did I miss anything?
I like that you mentioned that we're seeing the ability to make things we maybe dreamed about come to reality. So
Yeah.
Looking back on your experience, are there any standout moments where in your early experiments you got really excited or had a breakthrough moment that really stands out to you?
Yeah, so I think that just like everyone's, I think the GPT moment is indeed a big standout moment for me. And before that, I think deep learning is also a big breakthrough. But I would say the GPT, especially the ChatGPT moment, was the most exciting. But before that, I was mainly working on this automating machine learning, this Flamo open source project for tuning models, model parameters, choosing the right model for each application automatically. That covers both small models, large models, basically any machine learning models. But these GPT models and just ChatGPT experience is so powerful and different, such that I started also trying to apply the AutoML technique to the GPT models and see if we can also tune these models' inference parameters to get the best quality out of them while using the lowest cost, because these are so expensive. And during that work, I found many interesting behaviors and many interesting implications about how to build a very effective application using these powerful language models. I realized it's often not enough to just use the model, do the inference once, or use the same configuration once. Sometimes we need to use different configuration and combine them with different tools, or involve human in the loop to build the best experience and best application. So then I started to think about this more generic way to design these powerful applications, and try to think about the very large design space, but have a standard way, a relatively standardized way for developers to simplify the reasoning, to consider all different complexities in a relatively simple fashion. So I'm trying to find similar to the deep learning and machine learning time, people have been able to find some standardized API and interface for developers to build these models. Even when they can build different types of models, they all follow the similar kind of standardized interface. So that simplifies a lot of things and makes the automated machine learning possible. And coming from that background, I was really excited to try to find this common interface for developers to be able to build all different kind of applications, all different complexities and different domains in a relatively unified and simple language, and the way to reason about them and build them. So that's where I found this agent concept, very essential and useful concept that can simplify a lot of different things. And when the design AutoGen try to say, okay, no matter how complex the application is, let's make the developer's job really easy to just use 2 steps to build the application. One is to define the agents, and step 2 is to get them to talk. So as simple as that. And by the way, why get them to talk? It's because of the chat interface in ChatGPT. Reminds me of something I learned a long time ago, back in my college, about the power of the conversation. So when I see the ChatGPT interface, I immediately related that to that lesson I learned a long time ago from a professor at my college time. I learned that conversation is a provable way to do learning and to make progress and to eventually solve a problem. And that is some kind of belief, maybe rooted. But with this progress of GPT models and ChatGPT, those lessons got waken up, basically. And I quickly decided that I'm going to use this conversation as the key mechanism to combine and connect all the different agents and make them work more effectively as an integrated kind of system and solve bigger problems than they could alone. So back to the design principle about AutoGen, we want to have the developers to be able to build very complex applications in 2 steps, define agents and get them to talk. The agents, like I mentioned earlier, can be defined in many different ways. They can have different kind of simpler agents, or it can have more complex agents that utilize simpler agents inside them and have nested chat inside them. But no matter however they are, eventually they can use some convenient conversation interface to weave them together and make them perform different types of conversations and eventually work together to solve a problem. Yeah, that's a very brief introduction about what are the big moments that influenced the work and some design inspired by those big moments.
Yeah, that's great. I'm glad that you can put it in a few simple phrases, like build complex applications in 2 steps and define the agent and get a way for them to talk with each other. I'd like to hear a little more about the main focus areas of what you're working on now and how AI agents are fitting into that, and maybe why AI agents versus another approach. What about them is particularly well suited to what you're working on?
Yeah. That's a great question. Why did I choose AI agents as the essential concept when I try to find that standardized interface? There can be indeed many different ways to offer that interface. I think there are maybe several reasons, and but the most important one may be the design principle. Before I get to the agents, is that we need to remember what is the source of this new wave of technology evolution, right? So that is fundamentally it's because of the large language models. They are the newest technology and they are the most important technical breakthrough. So the initial design principle needs to be surrounded at them. So I was thinking about lessons we learned from previous operating systems or how we build the computer systems before. For example, when CPU and GPU were the most valuable resource, the operating system will be designed to try to maximize the utilization of these valuable resources, give them the right peripherals, like memory and other hardware and the software that make the best use of them. Similar lesson can be applied here. If we think the large language models are the most important and most valuable kind of resource we have, we can use them as a brain to essentially control the new type of systems. Then we also need to try to maximize the utilization of them. Okay, so that's the number one. That's where it got started. And then it's maybe not hard to understand why we think about agentic abstraction to use, because as we noticed, the most advanced language models, they are indeed able to perform different types of conversations that make them exhibit this intelligent and sometimes self-corrective behavior. So if we can make them work, we don't have to build applications in a traditional way such that we need to give them detailed instructions about every single step, what to do. These models sometimes are able to suggest a plan and follow the plan, and when it encounters unexpected result, they're able to discover the problems and debug and correct their mistakes. So if those capabilities can be well leveraged and makes agent concept work, then the development of application will be greatly simplified. And the opposite way is if we simply use them as simpler kind of text completion tool, then the developers often need to think about many different layers and steps, and that's more complex to build applications. Yeah, so basically, I'm trying to say that after some exploration and thinking, I got convinced that, especially with the progress of the model capability, I got convinced that in future, AI agents will be a very promising new way to greatly simplify development of any complex AI applications. And that is probably the most promising way to maximize the utilization of these power models. I think that's number two. I think number three is what about the limitation of the language models? At the time when I started to build agentic program framework like AutoGen, there were still a lot of limitations about what these language models can do in terms of using them as agents. If you simply put a language model and make them generate response, they don't always work. In many cases, they will hallucinate, they will generate wrong code, wrong answers. So at that time, it seemed not mature. It seemed not, so many people actually have doubts whether it's indeed the right direction to go. Yeah, when I think about it, I agreed that they were not ideal yet, but there are several things that made me believe there's indeed a good potential, and I don't want to make a bet and follow this path. One is we know that the model is still evolving. They're still getting better every time when the new version is released. So that's number one. And number two is I don't believe we should solely rely on the language model to build the agents in any case, even when the model evolves, because they often need external information to validate what they suggest. Even though when they become very good at reasoning, they don't necessarily have the information all they need when performing interactions. They don't necessarily know what the user wants exactly. The users may give a relatively vague request, and they will need to figure out what's the true intention by getting more information from the user. And when they suggest, for example, performing actions in certain environment, like in the user's environment, they don't also know everything about the user's environment. So they will need to get execution result in that environment to validate things. And also when external knowledge changes, when the world changes and have new information that our model didn't have when they were trained, they will also need to get up-to-date information. So in any way, I don't think model is enough to build useful agents. So we will need this type of non-model component in the system. And then, of course, you have the choice to have separated notions or concepts for each of them. But that goes against the principle of like simplifying the reasoning and the concepts. So why not try to find an approach that uses the same notion without introducing new concepts? Can we still use agents to represent them, right? So it turns out we indeed were able to use this nice, more general notion of agents to incorporate all the different kind of entities, but we make them very effectively work together through this conversational mechanism, conversation programming. And once I see that, it makes me a stronger believer that this agent concept and multi-agent, especially multi-agent conversation, is very generic, useful way or architecture to build any application powered by larger models. And as time goes by, I got more and more validation from different users and different type of applications from different domains that just make me more and more a strong believer in that.
Yeah, that all makes a ton of sense, and it's really interesting to hear that as you considered working with agents, you returned over and over again to looking at the advantages of one approach and the disadvantage of another. I'd like to know, are there elements that you found that significantly impact the effectiveness of an AI agent at the design level?
Yeah, there are indeed a lot of challenges still. I think it's a big open question. What is the most effective multi-agent design or architecture for a particular application? And how do we create this highly capable agent while ensuring like scale, safety, and human agency? These are all very difficult, hard, no, open questions. I think there are a number of dimensions that we need to pay attention to. One of them is evaluation. I think the evaluation is very important to measure the progress and understand are we doing better or are we not making any advancement, right? And this, for the agentic applications, is especially challenging because the metric is sometimes not easy to find. What is the effective metric for task completion? People can use like success rate, but it may be not enough. Even for the same success rate, two different systems can exhibit other different behaviors like number of steps they need, the cost involved, and the easiness to understand what they're doing, and the transparency, interpretability, all these kind of different metrics. But on the other hand, it's possible to build agentic evaluation framework, like building agents that are able to look into the behavior of other agents and reflect what are the important dimensions. We need to evaluate them, we can measure them, and then score the behavior for different systems. We have some initial ongoing work called agent eval that is essentially agent-based evaluation tools. We also have a benchmark tool called AutoGen Bench that helps users to download the benchmark and run them and get a sense of like how good is the performance. And these tools actually helped us to reach very good performance on the Gaia benchmark, which is a benchmark by Meta for measuring the capability of models or agents in solving very complex tasks that involve many different steps. Our initial experiment using AutoGen actually turned out to be the #1 performance on that benchmark at all 3 different levels just a few weeks ago. So we were excited by that because we knew there was still a lot of room for improvement. But this basically demonstrated the like big potential of using AutoGen to tackle the complex tasks. Okay, so that's about evaluation. And the second category I want to mention is the programming interface, or in general, the interface to build agents and make them work together. So we're making a lot of progress in that too. Why is that important is, like I said earlier, the best architecture is not found yet, and also it may be different for different applications. So we need a framework that allows people to quickly experiment with different ideas, different architectures, and in a modular way. Because if they want to make small modification by adding an agent or removing agent or modifying agent, we want them to minimize the change needed. And also, we want them to think about this problems clearly instead of having too many like coupled components so that it's hard to make any modification. So these are all the reasons that multi-agent framework like AutoGen is good choice for like modularity, flexibility, and simplicity. So, and then if we work together, the community experiment different ideas together, we could potentially make very fast progress. And recently, we are also making these different types of programming, conversation programming, more explicit. Previously, AutoGen already had this fundamental architecture that can support different conversation patterns. Oh, and we provide some examples of the high-level programming interface like group chat by having multiple agents talking in a group in the freestyle. But that was meant as an example. We don't mean that this is the only way to build multi-agent applications using AutoGen. And to make that more explicit, recently we also added a few more high-level constructs for a few other patterns. These previously users can build these patterns using the same basic interface conversable agents to achieve them. We also have examples, but with the newly added high-level constructs, high-level syntax convenience, it's even easier for users to choose those patterns like sequential chats, nested chat, and finite state machine-based group chat, which allows more control of the agent speak order in the group chat. We found that this simplification also greatly help with the practitioners to more quickly build a complex agent workflows. Okay, so that's about interface. And we also, not only for programs, but also we're building interface for like non-programs. For example, we had an example application called AutoGen Studio, which allows non-developers to quickly create agents and multi-agent workflows without writing code. So it's a no-code UI, and it got a lot of attractions too. I think that will accelerate the speed for experimenting with all these different implementations of multi-agents. And a third category I want to mention is the learning/teaching/optimization. This is an essential capability for agents to improve over time. For example, by learning from the past interactions, take teachings from users or from other agents, and improve over time. So the more people use these agents, the more they get better. One benefit of this is initially we can begin with some agents which don't always perform as desired, but without changing the design of them, if we give them the learning capability, then they can simply become better when users use them over time without changing the architecture or rebuilding the application, right? So they can start with the application with not so good performance, but as initially you can have some developers use them and teach them things. And once they get to the point where it's okay to be tested among a larger set of users, then it can get larger set of feedback, and gradually you can grow the capability and the effectiveness of this application simply by using them. So that was a very kind of early design principle when I started building AutoGen. I really want to enable this kind of experience. And we recently we have also added many such techniques in the AutoGen library. Some of them are about enabling any conversable agent to be able to take teachings, remember them in long term, and apply them in future tasks. That sometimes can have a big effect in the performance, even when you use the powerful GPT models. With the teaching and without teaching, the performance can be hugely different, and the effort required is relatively lightweight. So users often only need to teach once, and they could become very useful. And we also have techniques like having agents of different capability teaching each other, like having GPT-4 agent teach GPT 3.5 Turbo agent. And eventually what we get is both higher quality, higher success rate, and lower cost compared to using a single GPT-4 agent, because now many cheaper agents now can be used to solve complex tasks they couldn't before. Yeah, so we're also very excited about the progress in this area. And the fourth category is the integration with new technologies. Like for example, with different type of models, we can make them perform different tasks. Some models can be fine-tuned to be very good at certain specialized tasks with high performance and low cost. That also can potentially increase the effectiveness of the application while keeping the cost of experiments low, which can eventually lead to faster progress. And there are another example is integration with multimodal models, multimodal with gave agent multimodality. We have seen examples of using them for robotics, for embodied agents, and there are many creative agents that can be enabled by this different new capability. So in general, integration with new technologies, both in terms of models and other agentic techniques, would be a great way to make a leap forward, make new breakthroughs.
Yeah.
Yeah, we do have lots of examples of these in AutoGen. Yeah.
I did want to ask about autonomy because it's something that we're very interested in at Valory. So I'd like to know, have we or have you managed to create a truly autonomous agent? And if not, what steps do you think are missing?
Yeah, I think that's a equally tricky question.
And of course, one thing that's come up when I've asked this question in the past is that it's really important to define what we mean by autonomy, because by some metrics, we already have autonomous software and have for a long time.
Yeah.
But the level of autonomy that people expect from AI agents when they imagine what they can do is sometimes higher than what's possible. But we are sometimes seeing people make at least small steps towards it. So in your own work, are you seeing something that you consider autonomous that meets your definitions?
Yeah. So okay, I think I'm constantly amazed by how creative the community is in building all the different types of agents. So every time I'm surprised, I feel like we are getting. Oh yeah, I feel like people were now able to build agents that we didn't know whether they could perform that task in a more or less autonomous way before. So I definitely am seeing a lot of progress. Like one recent example I found is using agents to look at the Google Earth map and try to calculate the area for wildfire, right? So that can be considered as with a certain amount of autonomy, which I didn't expect to do before. So I think to some extent, in many application domains, we are seeing increasingly capable agents that can solve more and more tasks. Of course, once you solve some task, people always wonder, okay, can they solve bigger questions? Can they solve bigger tasks? It seems to natural progression. I haven't seen a fundamental blocker to enable the agents to solve more and more complex tasks. It's just like any software, we usually do this step by step. Before we tackle the current complexity, it's hard to get to the next level. And maybe at some time we'll hit a fundamental blocker. But it occurs to me that we're not in the blocker yet.
Yeah, that's great. So I think we can just expect to see iterative improvement over time as we get new capabilities. And most importantly, I think more people experiment. That's what we really need to move the field and the space forward. As more people try to solve for use cases, we're going to see more and more agents that we do consider like truly autonomous. And yeah, I know I'm definitely looking forward to that. Okay, I have one last question for you, and I won't hold you to any of these predictions, but do you have any predictions for like the near-term future of the field? Like, what do you think might be coming next?
In the near future, I would expect a number of more complex tasks getting big progress using the multi-agent frameworks. The recent breakthrough in the Gaia benchmark kind of hinted that. And that is just for that particular benchmark. But we also found recently from like software engineering development or video creation that we've already seen interesting progress in these more complex tasks before. And even though the absolute performance number is still in the low digits, like 10%, 20%, but I think the basic components are there. And because the potential of using multi-agents is very high, there's a big design space. I think currently people only explored a small fraction of that. So by exploring more in that space, I do see a very high chance people could make a lot of progress in these traditionally complex tasks, like by having agents playing different roles, talking to each other, performing multiple steps, and restart when necessary. This potentially can enable a large improvement over the short term.
It's really, really encouraging, and I look forward to seeing how that shakes out.
Another potential breakthrough is we might see smaller models getting more and more performant in specialized tasks, potentially also using AutoGen for the purpose of preparing the training data. One recent example I'm seeing is all-car math model, which uses AutoGen to prepare high quality and diverse training data for the math problems and fine-tune the small model just for that domain. It outperforms models like GPT 3.5 Turbo, which is of much larger size. And due to the quality of the training data generated by the multi-agents, the cost is also not very high. The training data size is not very large. It's quite manageable. And I think if this kind of success is repeated in many different types of tasks, then we should expect lots of progress in training the small size models and use them in applications which will greatly break down the cost and potentially even also improve the quality because of the affordability of the smaller models. So, and people can potentially build more complex multi-agent systems using them.
Yeah, that's fascinating.
Mhm.
So as we get to the end here, one last thing I like to ask all of my guests is if listeners or viewers are interested in this space and want to learn more, are there any learning pathways or reading recommendations that you like to give or places that you would point people who want to learn more?
So yeah, we are actively building new tutorials in our website and expanding that to cover also many advanced topics. For anyone interested in learning more specific topics, please reach out on Discord and suggest what to add. And also in general, I've learned a lot of new knowledge and new technologies from our Discord channel and new ideas. So having discussion and collaboration through our Discord channel is a very effective way of learning. I've found many successful examples from there. So yeah, tutorials, Discord, or involving on GitHub, I would encourage people to join these channels.
Perfect. So I'll get links in the description box or the show notes for people who are listening. If people want to follow you or know what you're working on, I can include your Twitter account. Is there anywhere else?
Yeah, please. Twitter and Discord and GitHub or LinkedIn. Yeah, so I'm most active on GitHub and Discord, but I also check Twitter and LinkedIn frequently.
Okay, perfect. Then I'll get links to your profiles in those places, and for people who want to, yeah,
Yeah.
keep up with what you're doing. Yeah, I want to thank you for your time. It's been a really interesting conversation, and I think people are really going to get a lot out of it.
Yeah, thank you so much. Yeah, really nice meeting you.
Yeah, likewise. All right, that is the end of this episode of AI Frontiers. I want to thank you for watching and or listening and invite you to check out what Valory is doing at valory.xyz. There you'll find out more about our open source framework for co-ownership of AI, ways that you can get started running your own decentralized autonomous AI agents, and much more. You can also find us on X where we are at ValoryAG. Okay, until next time.